Hey guys, we'll be discussing some more seesaw problems here. So let's talk about the same situation and we will see how we tackle them. Let's say I have a seesaw here and this is my pivot at this point. Let's just say this is a 10 meters seesaw here, right? Let's just say this is a 10 meters seesaw here. 10 meters. And the question says that the pivot is at the midpoint of the seesaw. This would automatically mean, or it should click to you that this is like 5 meters away from this point. This is at the 5 meters mark because 10 divided by 2 is 5 meters. So if it's midway between the seesaw, it's 5 meters definitely. So let's say this is 4 meters. Let's say this is the 0 mark, and let's say this is 1 meters, 2 meters, 3, 4, and 5, 6, 7, 8, 9, and 10. So this is 10 meters. So this entire thing is 10 meters. Let's say I have a friend here. I'll just change the color. I have a friend here who sits on the seesaw at this point, and he weighs around 200 newtons. Now, first of all, we should get the idea that he would be moving the seesaw in this direction, in the clockwise direction. His moment would be in the clockwise direction. And you should always get the intuition that whenever there's a perpendicular, you can see that there's a distance between the force and the region, as in the pivot, the fixed point. There's a distance between the force applied and the fixed point. There will always be a moment. So let's just calculate our moment, and we can see that this is a clockwise moment. So let's see, this is force times displacement. This is his weight, so this is the applied force. So this should be 200 times the perpendicular distance, which is this distance. This is 5. This is 5, and this is 10. This distance becomes 5 meters. So this is 5. The moment is 1000 newtons meter, which is clockwise. Alright, so let's assume now. Alright, so this is, let's make it a little difficult now. He is moving it like this, but I don't want it to be moved this way. I want it to be in equilibrium or in a stable position. So let's see. I bring in a friend, and because I'm not, let's say I don't weigh that much, so I bring in another friend with me, and we both decide to somehow just balance his moment. So let's see what we both can do. Let's say that I sit over here and I weigh about 100 newtons, and in this case I'm a smaller guy and I'm not as heavyweight as my other friend is. Let's say this is A, and I bring in a friend B, and I ask him to decide a place where he can sit so that we are able to balance the moment or bring this seesaw into equilibrium. And what are we actually trying to do? We have to balance his clockwise moment with the same moment in the anti-clockwise direction. Our aim is to somehow produce, this is our aim, to somehow produce 1000 Newton meter in the anti-clockwise direction. So let's say if I am here and this is my friend. He's here. Oh, let me just take this correct. He is here. And he weighs about, let's say, 150 newtons. So let's see what we can do where we should be sitting to balance the moment. First of all, let's imagine I'm sitting at this point. This is me exerting a force of 100 newtons at this point, and I'm sitting here, which is about 2 meters from here, right? So that's great. So let's say I am about 200 newtons. I am 200 newtons as well. I'm not the heavy guy. I'm not the light guy. I'm the heavyweight as well. So I am 200 newtons as well. All right. So although 200 newtons is not very heavy, it's just 20 kilograms. So, but still, in this case, 200 newtons is heavy. So let's find out what is the moment I am exerting if I sit here. So moment number 2 would be given by the same formula, F times t. In this case, we have the force, which is 200 times displacement, which is 2. This would give me 400 Newton meter. But we need to make 1000 Newton meter this is in the anti-clockwise direction, but it is not fulfilling the requirement. Our requirement is 1000 Newtons meter. So what we can do is I have fulfilled the requirement of 400 Newtons meter. The leftover moment is, let's say, 600 Newtons meter. The other guy has to fulfill the 600 Newtons meter requirement. So he has to choose a place from which he can fulfill the 600 Newtons meter. So that is our aim in this situation, because we know that sum of clockwise moment should be equal to the sum of anti-clockwise moment. In this case, the anti-clockwise moment is 1000. Sorry, the clockwise moment is, let's say, 1000. And for now, I have produced a moment of 400 newtons meter. But I need one more moment, which should add up with 400 and make 1000, which we know would eventually be 600 newtons meter. So the other friend needs to produce a moment of 600 newtons meter. So let's see what he's going to do. He was weighing 150 newtons. Let me just clear this up. So my friend, he weighed 150 newtons meter. So I know that he has to make the other 600 newtons meter. So this is newtons. I'm continuously saying this as newtons meter. If you're getting confused, I'm really sorry. But he weighed 150 newtons, and he has to make 600 newton meter. So let's see the distance. This is the formula, F times t is equals to moment. We know the force, but we are finding the distance, which I'll take as x. And the moment that he needs to produce is the leftover 600. So x is equals to 600 divided by 150. Just take over here. Use your calculators, you will get 4 meters. So this means that the other friend has to sit, this is the seesaw, he has to sit at a distance of 4 meters to the left hand side of the pivot. So if he sits here, he would be exerting a force of 150 newtons. I was sitting here and I was exerting, this was 2 meters. I was exerting a force of 200 newtons. And this guy, the other friend, he was sitting here and this distance was 5 meters, and he was also exerting a force of 200 newtons. Now you can see that if I calculate the sum of anti-clockwise moment, this would give me, both of these forces would give me anti-clockwise moment, because this would take it here as well, this would take it here as well. So let's just find out the sum of these two moments. This would be 150 times 4 plus 200 times 2. this is the sum of the anticlockwise moment, and this should be equal. If we have to bring it to equilibrium, this should be equal to the anticlockwise moment, which is 200 times 5. So this is 4 into 150, we know is 600 times 400. This is equal to 1000, and this is left hand side is equal to the right hand side. So in this case, this will not move and will stay in equilibrium. So I hope you guys have an understanding of this situation, and we'll be doing more examples on this, and we'll be solving more puzzles of moments. We will see how they're very useful. So thanks for watching, guys.